So that is case number 2. So in our case number 2, we have to prove. So this DeMorgan law 2. So in our DeMorgan's law 2, we have to prove that negation of P and Q is identically equals to negation P or negation Q. Then now the solution starts. So in our solution, so as per the problem or as per condition which is to be proved is of negation of P and Q is identically equals to negation of P or negation of Q. But here, in order to prove this condition, we have to assume two statements, that as one as P and other as Q. But in order to prove this condition which is given, we have to write the truth values of the left hand side and as well as the right hand side. In case if the left hand side truth values and the right hand side truth values are similar, then hence we can state that the LHS is identically equals to RHS. So therefore, negation of P and Q will be identically equals to negation of P or negation of Q. Then now, the next logical step, the condition which is to be proved is of so here we have to prove negation of P and Q is identically equals to negation of P or negation of Q. But here let us suppose, so here P and Q are two statements, or in other words two simple statements. Then now here this is the truth table in order to prove the condition which is negation of P and Q is identically equals to negation of P or negation of Q. So here we have suppose two statements, whereas in these columns, so here let us suppose the P under the first column and Q under the second column. So these are the 7 columns and these are the 7 columns. So in our first two columns we have supposed, so here two statements, one as P and the other as Q, whereas in order to find out the LHS, first of all let us find out the bracket that is P and Q in the under the third column. Then now let us find out the negation of that bracket that is P and Q under the column number 4. Then on RHS we need negation P, then similarly we need even negation Q also. Then now on the whole the RHS is of negation P or negation Q. Then now here let us find out the truth values of these simple statements. So here when we assume a single statement, as per the definition, say a statement may be either true or false but may not be both. So here here we have assumed two statements P and Q, so therefore the possibilities will be of 4. So they are of, one is as true, the other is of false and false. If one is of the true statement, then the other may be false. If first one is of the false statement, then the other statement, that is the second statement, may be of true. So here these are the 4 possibilities, that are TT, FF, TF and FT. Then now let us find out P and Q. So and indicates the conjunction. So in case of a condition, the condition is of. So here in case of a conjunction, the condition is of, if the first statement is of true and the second statement is also of true, then automatically the conjunction also will be of true. Then now, so we have to search T and T under the columns P and Q, that is first and second columns. So here true will be of a conjunction true, then in other cases T and F and T and F, so it is not possible. Therefore the remaining all truth values will be of false under the conjunction that is P and as well as Q. Then now let us find out the negation of this conjunction that is P and Q. So here negation of the two statements, conjunction of the two statements P and Q is of. So here P and Q is of true, then the negation will be of false. So here in this case, if it is of false, the negation will be of true. So false and false, the negations will be of true and true. Then now let us find out the negation of the statement P. So here negation, the truth values of the P are of T, T, F, F, therefore the negations will be of. If it is in case it is of true, the negation will be of false. Then the P is of true, the negation will be of false. So here the truth values are of falses. So under the statement that is true, statement that is P, therefore the negations will be of true and true. Then now let us find out the negation of Q. The statement Q is of, truth values are of TF and TF. So here the truth value of the statement that is Q is of true, therefore its negation will be of false. So in case if it is of false, the negation will be of true. Then in the last two cases T and F, therefore the negations will be of F and T. Then now let us find out the negation P or negation Q. So here it is the collective is of R, which is denoted by means of the symbolic, that is V. So here since it is V, or it will come under the disjunction. So in case of a disjunction, if the first statement, that is negation P, is of false, and the negation Q, the second statement, is also of false, then the disjunction will be of false. That is, we have to search F and F under the columns negation P and negation Q. Negation P is under 5th column and negation Q is under 6th column. We have to search under 5th column and 6th column for F and F. So F and F, the disjunction will be of. So here none other, F and T is there, T and F is there, and T and T is there. So here the remaining all the truth values will be of true. Then now in order to prove this condition, that is negation of P and Q identical equals to negation P or negation Q, we have to see the negation of P and Q. Negation of P and Q is under the column number 4, and the negation P or negation Q is under the column number 7. So we have to see the truth values of column numbers 4 and as well as 7. Whereas here, so here the truth values are of FTTT. So here also the truth values are of FTTT. Since the truth values of the columns 4 and as well as 7 are similar, so hence LHS is identically equals to RHS. So here we can write it as, since truth values of columns, that is column numbers 4 and as well as 7 are similar, hence, so here LHS, that is the column number 4, that is negation of P and Q will be identically equals to, say column number 7 is of negation P or negation Q. So here in this manner we have proved that negation of P and Q is identically equals to negation P or negation Q.